Step Talks Education. Let us look at yet another example of a question that can be set in paper 2, which comes from the area of ionic chemistry and qualitative analysis. So let us try to analyze this question here. It says, when a green powder P was heated strongly, when it was heated strongly until no further change, a colorless gas Q, which does what? Which turns lime water milky. I have already got something from here. A gas which turns lime water milky. And a black residue, that means a black solid R, got from the process of heating this green powder. So they were formed, and solid P was then dissolved in dilute hydrochloric acid, and a blue solution S was formed. When ammonia solution was added to 1 cubic centimeters of solution S, dropwise until in excess, this is now qualitative analysis test. When it was added dropwise until in excess, a pale blue precipitate T formed, which dissolved in excess ammonia solution to form a deep blue solution U. So this is pure qualitative analysis question. So let us try to do the analysis slowly. When a green powder P, I'm saying it is green, meaning that it may be containing copper 2 ion, or it may be containing iron 2 ion, and it is a powder, meaning that it may be a carbonate. I'm trying to come up with the exact identity of these substances here. So when it was heated, it underwent a thermal decomposition on heating because something was formed. It was heated until no further change strongly. They say the colorless gas Q, which turns lime water milky. So the gas is carbon dioxide. Simple. So I cannot wait. I'll just go and put my gas Q being carbon dioxide. I cannot just wait. Carbon dioxide. Then, and a black residue R. We said that from the process of heating, when you get a black residue, then that one is likely to be copper 2 oxide. So the residue is R. So this one is copper 2 oxide, our black residue. Remember what we got from the action of heat on substances. So we have copper 2 oxide, which has been formed. Let me make carbon dioxide very clear for many to see. So this is carbon dioxide, and that is the gas. Now I can now come back and I identify the green powder P. It is green in color, meaning that it may be having copper 2 ion or iron 2 ion. But since the residue is black, meaning that the residue is copper 2 oxide, and then it produced carbon dioxide. So it means that this one has been a carbonate of copper. That means my solid P is copper 2 carbonate. It is copper 2 carbonate. Since it is a carbonate, it is powdery, and being green, it is containing copper 2 ion. We are moving on well. Then let us continue. They said that solid P was dissolved in dilute hydrochloric acid, and a blue solution S was formed. The blue solution S formed when copper 2 oxide is dissolved in dilute hydrochloric acid. We get a salt of, because if a base copper 2 oxide reacts with an acid, dilute hydrochloric acid, we get a salt and water. So our salt is copper 2 chloride solution. So this is the name of our blue solution S. We should write the equation for the reaction to show the effect, equation to show the effect of heat on powder P. So our powder P is copper 2 carbonate. So we are going to write the equation for the thermal decomposition of copper 2 carbonate. So copper 2 carbonate, when heated, it decomposes into copper 2 oxide, which is a solid, that's the black solid, and then carbon dioxide gas, which is the colorless gas, which turns lime water milky. So we get also carbon dioxide gas. Then we should write the equation for the reaction between the black residue. Our black residue is copper 2 oxide and dilute hydrochloric acid. So let us write the equation very easily. It is copper 2 oxide reacting with the dilute hydrochloric acid. I'm trying to be as careful as possible so that I write a very nice and a neat equation. So copper 2 oxide reacts with dilute hydrochloric acid. A base and an acid reacts to form a salt and water only. So the salt is going to be the chloride of copper, which in this case is copper 2 chloride solution. It is a soluble chloride salt, by the way. Remember, it is silver chloride, lead 2 chloride, and then the mercury 1 chloride, which are insoluble chloride salts. Copper 2 chloride is a soluble chloride salt. That means that it will be formed as a solution but not as a precipitate. So we also get water as a result of this reaction here. So let us balance the equation. We have 2 chlorine atoms on the product side. We have to multiply by, hydrochloric acid by 2, and hydrogen atoms becomes 2. There are also 2 on the product side. Copper atom, we have 1 here. On the product side, also 1. Then on the reactant side, 1 oxygen atom, and it's also 1 here. Our equation is just balanced. So we are good to go. This is the equation for the reaction between the residue R, which is black in color, copper 2 oxide, and dilute hydrochloric acid. We write also the equation for the formation of the pale blue precipitate T. Equation for the formation of the pale blue precipitate T. So how was T formed? T was formed as a result of the reaction between the blue solution, that is copper 2 chloride solution, and our reagent, which is sodium hydroxide solution. So let us see what takes place here. We shall have exchange of ions, whereby the copper 2 ion will come and pick the hydroxide ion, and we get copper 2 hydroxide, which is our, in this case, the pale blue precipitate formed as a result of, it is not sodium hydroxide, but the ammonia solution, which is ammonium hydroxide. So it is not just blue, but pale blue because of the ammonium hydroxide being a weak alkali, hence providing very little or liberating just a few hydroxide ions because of the reversible process, the backward process that uses the hydroxide ions formed. So we get a pale blue precipitate of copper 2 hydroxide. It is a base, not an alkali, so it will be precipitated together with the salt ammonium chloride. Capital C, small l, and this one is aqueous. Please don't let the letters touch each other. So let us balance the equation. We have 2 chlorine atoms. We multiply ammonium chloride by 2, and then we have got 1 nitrogen atom. Here we have 2, so we multiply ammonium hydroxide by 2, and then our equation is balanced. Or we can also write the ionic equation alternatively, because we have not been restricted to writing the ionic equation or to writing the formula or the formula equation in this case. So let us write the equation for the reaction in terms of the ions. That is it, the ionic equation. In copper 2 chloride solution, we have the copper 2 ion, which is not on this side. We have 2 chloride ions, which are free ions, and then we also have 2 chloride ions in ammonium chloride. so they will cancel their spectator ions. We have 2 ammonium ions here free in the aqueous solution, and also we have 2 free ammonium ions in the aqueous solution, so they are also spectator ions. Hydroxide ions, the free hydroxide ion is not here. This is a solid, so we shall have copper 2 ions combining with 2 hydroxide ions, and we get in this case our copper 2 hydroxide, which is precipitated as a pale blue precipitate. So this is what we had seen earlier, and it has now got us here in this question. Then we write the formula of the ion in the deep blue solution. U. The deep blue solution is formed when the pale blue precipitate dissolves in excess ammonia solution. So we see that it is called the tetraamine copper 2 ion, NH, tetraamine copper 2 ion. And the whole of this one we bracket it and we put our 2 plus here. So this is the formula of the ion in the deep blue solution. Remember, the name is tetraamine copper 2 ion, as we had seen before. And you can see we have got a very nice question, and we have applied so much the knowledge of qualitative analysis in getting the answers to this question here. So with qualitative analysis, we can stop here. Thank you for watching Tech Talks Education. Please, if you have liked our videos, please, you need to press the like button and we'll be on the same page. Thank you.